Good morning, students. In the preceding sessions, we have gained very much knowledge on the Verilog, its basic features as well as some of the essential features that is required to develop an effective design. So, in this session, we are going to discuss some of the modeling techniques that are highly useful, which makes the Verilog an flexible as well as a powerful language for modeling any hardware design. So that means here we are going to study some additional features that improves our Verilog language and how it is going to make the language powerful for modeling our hardware design is the topic for today's discussion. So in these modeling techniques, we are going to cover the concepts like procedural continuous assignments, overriding parameters, conditional compilation and execution, timescale, and some of the useful system tasks. So coming to the first topic, that is procedural continuous assignments. So before going to this procedural continuous assignments, we are having certain knowledge on procedural assignments. So what is this procedural assignments? These assignments generally assign some value to a register. Like I am having here two registers, those are A and B. So after assigning some value to these registers, the value that is A equal to 1 and B equal to 0 will be staying in the register until I assign these registers with some other value, some other procedural assignment I done. Until and unless I make some certain changes, the value will not be getting lost here. So that means here I can say the value stays in the register itself until some other procedural assignment I am going to do here into those registers. But coming to, yeah, you can see here that A equal to 0 and B equal to 0. That means this is the one what I have done. This part I had made after 5 seconds. That is, after 5 seconds I had done certain changes such that the values in the register are changed. Okay, then what will be the difference with procedural continuous assignment? Like how they are not alike with procedural assignment? We'll see. The procedural continuous assignment, they generally are different when compared to your PA, that is procedural assignments. As these PCA, I sometimes going to call these procedural continuous assignments as PCA. So this PCA allows value of any expression continuously onto the registers or nets only for certain amount of time, only for certain period of time. So like what is this certain period of time, why I am stressing this statement is, we'll discuss this one with its types, then you can able to understand what is this certain amount of time. Okay, so in this procedural continuous assignments, this allows a value like this. You can able to see the statement what I have mentioned in the slide. Like these override existing assignments to a register. That means I have a variable. That variable may be of type register or it may be of type net or wire. So they are going to override the existing assignments to a register or net. In the above example, I am having here two registers A and B. I am going to override. That means A1, B0 I have taken. So these values are being overridden by the procedural continuous assignment only for certain period of time. So after that certain amount of time, these overridden values are released. That means this register which got these register variables which are got overridden by some assignments, they are now in free state. Okay. The procedural continuous assignments generally available in two formats. one format, I mean to say the first type of procedural continuous assignment is done or is given by the keywords assign and deassign, and the second format or the second type of procedural continuous assignment is done with the help of force and release keywords. That means these first step as well as the second step, the keywords whatever we are using in the first step and second step, they are overriding the registers or net variables only for certain amount of time. This you should be keep in mind. Okay, so let us discuss about the first type of continuous procedural continuous assignment, that is with the help of assign and deassign keywords. So by using these keywords, sorry, so you can able to see here assign q equal to 1 bit binary 0 and deassign q. So assign and deassign here stands for the keywords that we use in the procedural continuous assignments. So here there are certain characteristics in this PCA. That means the first type of PCA are expressed by assign and deassign, which works only for register data types. That means it won't be working for net data types. I will explain you what is it. It is only working for register data type. I will explain you by taking an example. And the left hand side of your PCA, that is left hand side of your PCA should be a register. Okay, Q should be a register, or it may be a concatenation of registers. We will see. And assign keyword overrides regular procedural assignments. Deassign keyword re-enables it. Okay, so after deassigning the variable, the last value will be remained on the register variable until a new procedural assignment update it. And PCA override regular procedural assignments for controlled period of time. Okay, that is fine. Let me take one example for demonstrating you what is this assign and deassign and what is the purpose of them. So I would like to show you this one by simulating in Xilinx ISC, such that you can able to understand the things clearly. Let me copy the code from here. Yes, new source. Verilog text feature Verilog module. It is, I think so. Yes, it is Verilog module edge underscore dff. I am just copying the code here. Okay, let me also copy the simulation block for this one. Module stimulus is the top level module name or the test bench name, and Verilog test fixture, this is the one what we need to select for writing the test bench program. Next, yes, next, finish, right. So one more test bench file will be created here. So module control V, this will be better. So now I am going to explain you each and every statement what in our PPT I have read. The first type of PCA are expressed by assign and deassign, right? And which works only for register data types. So which works only for register data types here. So here you can able to see I am having my module name, that is edge triggered D flip flop. I am taking actually HDFF, that is HD flip flop, whose outputs are Q and Q bar, inputs are D, clock and reset signals. So if I am going to write this program in the behavioral abstraction, generally input declaration I have to do, it is must, and output declaration also it is must. But if it is in behavioral abstraction, definitely the outputs have to be exclusively mentioned with reg as a keyword, that is reg, q and q bar. Okay, so always iterate negate clock begin q equal to d, because this concept you know what in the d flip flop whatever the data is entering, q will be collecting that incoming data and q bar will be negation of d. So as I have mentioned you that any always block or initial block, the activity flow will start parallelly. That means this block starts execution at simulation from simulation time 0 onwards, as well as this block also will start execution from simulation time 0 onwards in this manner. That means these two blocks will start executing parallelly, because these are the two always blocks that we are having here. Okay, so just forget about this one, because this is the general concept. Now always at the rate of reset, that means always I need to depend upon my input variables. So always at the rate of reset, what is happening? If reset is present, begin assign q equal to 1 bit binary 0. So whenever we are doing reset to any sequential circuit, what happens? The output will be redirected to the 0 values. So that means assign q equal to 1 bit binary 0, and if q is 0 means definitely q bar will become binary 1. Okay, else if it is else case, that means there is no reset I have done here, else. So that means here what is happening, we are discussing the procedural continuous assignment, that is first type we are discussing. That means generally the activity flow will be like this: q equal to d and q bar equal to negation of d. That means whatever the incoming data that is passed to or collected by q output port, and q bar also the same. So if reset is being pressed, what happens? I am forcing my q and also I am forcing my q bar. So I am overriding the regular assignments to q. So the regular assignment of q is what? This one, the regular assignment. That means that d is assigned to q regularly. Okay, so this regular assignment is being overridden. When it is to be overridden? When reset signal goes high. So whenever your reset signal is going high, assign q equal to 1 bit binary 0. I am overriding your q because I have done the reset here. Whenever reset is being done, all the outputs must be turned to logic 0 state, and q bar, of course it is a negation. Q and q bar are the opposite signals, so q bar equal to 1 bit binary 1. So this is the usage of assign keyword. Okay, so for how long this will be, for how long q will be overridden, that means overriding the regular assignment, for how long q is under the overridden state, that depends upon the simulation time for reset. That means for how long your reset signal is in logic 1 state, for that long amount of time your q and q bar are being overridden by your first type of PCA, that is you assign keywords. Okay, whenever your reset signal is going low or less, that means de-assign q and de-assigning q bar. That means I am releasing, I am making my variables q and q bar into a free state. That means it is a frozen state, it is a free state. I am just releasing it. Okay, so this is the usage of assign and de-assign keywords. Now let me simulate this program first, and after that we can able to analyze how this assign and de-assign exhibit in the simulation waveform. Okay, so I have written the code for the same simulation. This is a module stimulus register. So like d clock reset, these are acting as an inputs. So in the test bench, these are the signals. So these signals should be of type, these are the incoming signals or input signals to your design block. So these input signals should be of type reg, as we discussed in the previous sessions, and q and q bar, these are the output variables or the output signals which are collected from the design unit, and it is of type wire. It should be and it must be of type wire. Okay, so edge DFF. So I am instantiating my design unit inside my stimulus or the top level test bench block, that is stimulus block. So edge DFF is my instance name, and whatever the ordered list I have maintained here, the same thing I need to follow here, like Q bar, D, clock and reset. So initial begin clock equal to 0 because it is I have completely dependent on my neck edge clock. So let me start with the clock equal to 0. That means the clock is initialized to 0 here. After that, let me send some data, that is D equal to 1. So after 10 seconds, I just made reset equal to 1. After next 10 seconds, reset equal to 0. That means the reset equal to 1 will be sustained for 10 amount of time, 10 seconds amount of time. Seconds I am mentioning, but it is not real time seconds. For your understanding purpose, I am using here seconds. Okay, because it may be a nanosecond or picosecond, what it is I don't know. So for our understanding purpose, let me like use with seconds itself. So after 10 seconds, reset equal to 1 will be for 10 seconds, and after it reset equal to 0. That means reset is released. And always hash by clock equal to negation of clock, because clock signal whenever I am using inside my design, it is a continuous activity. Clock is a continuous, that means it is continuously generating a infinite number of pulses until and unless I give dollar finish or dollar stop inside my stimulus or the test bench program. So always hash 5, because always and this initial, this block as well as this block runs parallelly concurrently, they execute independent to each other. So after this one we do have the end module. So let me simulate the program, and with the understanding of my stimulus block, you people can anticipate for how long your Q will be in 1-bit binary 0 and for how long your Q bar will be 1-bit binary 1. It is completely dependent on your reset signal. So by seeing the test bench, you can able to see that my reset signal will be in logic 1 state only for 10 seconds amount of time. So only for 10 seconds these Q and Q bar are being overridden by your PCA, overridden here. That means the regular assignments for Q and the regular assignment for Q bar is being overridden. That is what it is giving us the meaning. Okay, so let me simulate the waveform, and let me simulate the test bench, and later we can discuss the analysis of waveform window. Yeah, I have simulated something here. Let me check. So by seeing here, what is that one? Initially clock equal to 0 and clock is toggling for every 5 seconds. Let me see in the waveform window. So this is my clock signal. For 5 seconds clock is toggling, here 0, here 1, here 0, here 1, here 0, here 1, right. And next is clock, okay, initially clock should be 0. Is it 0? Of course it is 0 only. And after that d equal to 1, initially d equal to 1. So where is my d signal? Here. So d equal to 1 is a constant I have maintained, d equal to 1, because you can see here, it is indicated here also. For everywhere your d signal is 1. And after 10 seconds reset goes to logic 1 after 10 seconds. So 0 to 10, that means of course it is a nanosecond. For I said you right, it is for understanding purpose I am using seconds. So 10, after 10 nanoseconds your reset is going to high. Am I right? Before 10 nanoseconds reset I didn't given any value for this one, and after 10 seconds only I have made my reset signal for logic 1. And after 10 seconds, that means reset equal after, that means after 10 seconds your reset equal to 1. So for how long this reset equal to 1? For again next 10 seconds. After next 10 seconds your reset will be equal to 0. So that means after 20 seconds, 20 nanoseconds, your reset will be equal to 0. So during the time of reset, what is happening here? During the time of reset, I am having here my a q and q bar are what happened to them. So if reset is going high, I'm just overriding the regular assignments for q with the new values using my assign keyword, that is procedural continuous assignment keyword. I am overriding the regular assignments to q. So assign q equal to 1 bit binary 0 and assign q bar equal to 1 bit binary 1. So this is what I have done here. Okay, so that means this overridden thing will be sustained for 10 seconds amount of time. Okay, so during this one q equal to, what is the status of q? Yes, it is q equal to 1 bit binary 0. That means during the time of reset, and is a q bar equal to 1 bit binary 1 up to the 10 seconds. So after that one what happened? So if reset, that definitely and certainly it goes to low, else case, that is else case I have released. That means I have removed my overriding values by using the deassign to my q and q bar register. After this, the q and q bar will be able to change the registers on the next negative edge of your clock. That means here what is happening, simple thing. When reset is going high, we override the assignments on q and q bar and assigned new values to them when the reset signal is logic 1. So these are the new values when reset signal is logic 1, and so the register variable will retain the continuously assigned values after the deassign. So that means this register variable will retain its previous value. So whatever the previous value, that means whatever the d value is having, that will be retained here. You can able to see. So here the previous value of q is what? Q equal to logic 1. So now after 10 seconds of your reset, that means from this duration to this duration, assign keyword comes into an active mode. After this 10 seconds, the assign q and q bar have done. So at this amount of time, the register variables q and q bar retains the continuously assigned value. That means q equal to d. This is the continuously assigned value for q and q bar by using the deassign. So this is what happening. That means it is just a retaining, q and q bar are retaining its previous values. So that means q and q bar are strictly following here d signal or the d variable. So for suppose in my program, what if I have done like d equal to 1. So after this one, if I make like d equal to 0, so I am changing here my regular assignment. Previously it was d equal to 1. That means after 20 seconds my d equal to 0. So now q equal to 0 it will be happen, and q bar equal to 1 it happens. In this manner, the first type of procedural continuous assignments can be analyzed. Let me close the window. Okay, and we do also have the second type of PCA, that is with the help of force and release keywords we can able to like design our Verilog code. But why force and release second type of PCA is used? As most of the designers had felt that assign and deassign keywords or the constructs, these are had considered as a bad coding style kind of thing, and so they have found an alternative style instead of using the assign and deassign keyword for effective coding for their hardware designs. So like what will be because we do have also the restriction here with the help of assign and reassign keywords, as they should be and strictly used for register data types. Okay, so here we have got some demerit, and the engineers are also considered it is a bad coding style because of some as a many number of times repeatedly they need to use like assign, deassign and some kind of thing. So then alternative procedural continuous assignment came into existence with the help of the keyword, that is force and release here. So what is this force and release? So a force and release, these are the keywords which are useful in our PCA, that is procedural continuous assignments. Mainly and especially they are picked for interactive debugging process, that is only for the stimulus block. Inside the stimulus block only force and release keywords can be used. So these keywords can be applicable for the registers as well as net or the wire data types. So register variables or the wire variables can be forced to a value, and also they can be released from a value. So a force on a register, what happens? So here a kind of thing out, let me consider it is a register. So this out is a register, and a force on this out register overrides any procedural assignments or procedural continuous assignments, I can also say, on this register until the register is released. So once the register is released, the register variable will continue to store the forced value after also being released. Like I can demonstrate this with the help of an example. Let me read out all the statements what I have presented in the slide. Yeah, this one I have read. This one also, force keywords override. Yeah, all procedural PA means procedural assignments, PCA means procedural continuous assignment, and CA means continuous assignments. Okay. Yeah, even after releasing, the register variable may store the forced value, but this value can be updated by next procedural assignment. So let me take an example. Yeah, this one is the example. Just to save me the program. I have designed my HDFF instead of using behavioral abstraction. I have used here data flow abstraction level. So stimulus block I developed in this manner. So initial begin I am having here. So hash 50 force dff.q equal to 1 bit binary 1, and hash 50 release dff.q. So as I have mentioned you that force and release, these are especially used for the interactive debugging purpose only. That means in the stimulus block or in the test bench block only we need to use this force and release keywords. So these keywords can be applicable or they can be used for a register variables, or they can also be used for the net variables, because in the previous first type of PCA I mentioned you that assign and deassign keywords are used especially for the register data types, But coming to here, force and release, these keywords can be used both for the register as well as the wire data types. So let me check out how the code is behaving now. Let me copy these things also. Copy, yes. So initially clock equal to 0 and d equal to 1 as 10. Yeah, clock should also toggle it, right? That means always the clock is a continuous process. It should toggle continuously. So completed my test bench. I have saved it. So initially clock equal to 0 and data equal to 1. After 10 seconds reset is going high, and after that reset is going 0. That means reset will be high for only 10 seconds amount of time. Okay, so can I say that the activity, the original activity will starts from after 20 seconds onwards. So 20 seconds onwards, so 20 plus 50, 70. That means here at 70 seconds amount of time I have forced my wire variable, that is q, to 1 bit binary 1 for how much amount of time? For 50 seconds. So after 50 seconds, that means after 120 seconds, I am releasing my forced q, that is of type wire. Okay, so let me simulate this program and demonstrate you. Yes, I have got something. Let me check. So whether this waveform is strictly following what are the instructions that I have given in the simulation Verilog code, we'll check now. So clock is initially it is 0 and data is equal to 1 initially, and clock is a toggling activity. That means for every 5 seconds it is toggling like this clock. Okay, so according to the instructions given, reset will be high for 10 seconds, and the reset goes to logic 1 after 10 seconds. So after 10 seconds it is going to logic 1, and for 10 seconds, that means for 10 seconds amount of time it will be in logic 1 state. So where is the reset signal? Yeah, here. So after 10 seconds it will be logic 1, and for duration of 10 seconds it will be in logic 1. So that means at 20 seconds reset is going to logic 0. Okay. So after that 20 is over, 20 plus 50, 70. That means at 70 seconds the q value is forced to 1 bit binary 1. The q value. So what is this q value? Yeah, after 70 seconds. So you can see here, let me make certain change. D equal to 0 I would like to keep now. Yes, let me make a d equal to 0 control. Yes, relaunch the design. Yeah, so initially d equal to 0, my data before it was logic 1. Now I had made my data, that is d equal to logic 0 continuously. So rest of the things I didn't change it. And coming to after 70 seconds, I am forcing my q, that is wire data type, to 1 bit binary 1. That means from 70 seconds q is forced to 1 bit binary 1. Then what was the previous value of q before 70 seconds? It was logic 0, but after 70 seconds I am forcing it to binary 1, 1 bit binary 1 for how long? For 50 seconds amount of time. That means 70 plus 50, it is 120 seconds. So after 120 seconds, that means 70 plus 50, 120 seconds, I just made released. I have released my q variable. So whenever I am releasing it, the previous value of q is restored. So what was the previous value of q here? It is logic 0. The same thing will be appearing here itself also. Okay, so you may ask me a question, sir, will not the q value will be changed? Won't the q value will be changed? That means yes, it will definitely going to change, as q is completely dependent on d here. That means data input. So according to the concept of the flip-flop, the q is always collecting the incoming data of your d flip-flop. So whenever, that means, can I write as the equation q equal to d? So procedural assignment, it is nothing but, so I can say that the value of q will be altered until some procedural assignment has been updated. Okay, so whenever d equal to 1 is given in the test bench, q value also will be changes. So this is the purpose of a release keyword. So it is the demonstration for the force and release keywords for your second type of procedural continuous assignments. Okay, so coming to here, force and release we discussed. Okay, so the next concept for your useful modeling techniques in your Verilog HDL is overriding parameters. So what happens, why we have to override the parameters here is excuse me, here for example, we have defined parameters in a module definition. Okay, parameter is a keyword we have used because we have discussed this concept in our previous preceding sessions. During the compilation time, parameter values can be changed for every module instances. If I want to change the parameter value for every module instances, and I want to give some different values for those parameters, how to do these things? This is the concept that comes under the overriding parameters. That means overriding parameters allows to pass a distinct set of parameter values to each module instance during the compilation only. So these overriding parameter concepts can be done by using two techniques. One is a defparam technique, and the second is module instance parameter value assignment. So let me explain you. Defparam, this is my defparam statement. So that is I'm discussing about the first type here. So here what is happening, as I have said you that the parameters value can be altered separately for each module instances. Okay, so this defparam statement, it is used to change the parameter values in module instance by defparam keyword. Let me take an example here. So this is my defparam keyword, defparam, and the parameter hierarchical name and value. So module example I am taking now. Module here, module name is just Singham. So parameter, so in that Singham movie we do have hero, heroine, villain, all those different parameters we do have here. So parameter villain, who is the villain here? Prakash Raj. Prakash Raj is the villain for Singham movie. Okay, so this is something will be there, and end module. Next, if I want to instantiate this module in some other module, that is module top or module test bench. So in my module, in my top module, I am going to instantiate 2 times Singham. So that is Singham S2, Singham S2. That means Singham 2 and Singham 3. So in the movies of Singham 2 and Singham 3, do we have the same villain here? No. So that means villains are changed. How? That means, can I say the parameter values are changed? So if this is my parameter name, so the value assigned to the parameter has got changed, right? So how to change the parameter value for any module instances? So here my S2 and S3 are the instances. So if I want to change the parameter values, the format I need to follow is defparam S2, that means instance name dot parameter name and parameter value. So that is Sapani is the villain for Singham 2 and comma. So next is instance tree instance. Next instance name is S3 dot parameter name and value, that is Thakur Anup Singh is the parameter value that is assigned to the instance tree. Okay, module instance tree. So in this way the parameter values can be overridden during the time of instantiation. And so you can able to see the next technique, that is module instance parameter values. So in this module instance parameter values, what happens and similar like why we are using this one is the designer also felt the defparam as some kind of bad coding style, like you can see here. The next technique is module instance parameter value, where a new parameter values are assigned during module instantiation time only. That means we are not separately going to use defparam keyword and changing the parameter values. So whenever I am doing instantiation, module instances are done at that time itself only, my parameter values are assigned, are passed to my module instances. That means the new values are passed to my module instances. So here that means my top level module, that is TOP, can pass parameter to the instances S2 and S3 as you can see here. So where I didn't use anywhere defparam keyword, but anyhow it is leading to my same simulation output. So now that means parameter value Danny Sapani is passed to instance module instance S2, and this parameter value Thakur Anup Singh is passed to my module instance S3. So you can observe some difference here in the two instructions. That means in the second line as well as in the third line, some kind of difference you might have observed. So this in the second line, this kind of assigning parameters, this style of assigning parameters is nothing but parameter value assignment by ordered list. So whatever the order, that means I need to follow the same order here. And here in the third line, this style of assigning parameters is nothing but parameter value assignment by naming list, that is naming list. So you might be asking me a question, if single parameter it is okay, like because here villain is the parameter name, that means it is a single parameter. So if I am having multiple parameters are defined in a module like this, like parameter villain, parameter hero, parameter comedian, so multiple parameters are there in a module. Okay, so now during the module instantiation, they can be overridden by specifying some new values in the same order as the parameter declarations. Okay, let me explain you with an example. This one. Yes. Okay, good. Yeah, first I will explain you this example. That is by using defparam. So module main robot. Robot is the main module. So parameter. What is the ID number for your main robot? I have taken here the example of your robo movie. So parameter and its ID number is 0. Okay, so initial something will be there and end module. Then in the module top, that means your chitti, the main robo, is designing 100 number of its replicas. So like in this program, your main robot is instantiated twice with instance name as w1 and w2. So these are the instance names. Okay, so definitely if there are different instance names means, as my main concept is I want to override the parameters. Overriding of parameters is the concept. So id num, this is a parameter name and this is 0 is a parameter value. So the same thing cannot be present for every module instantiation, for which I have used defparam as the keyword. Defparam and hierarchical name. Hierarchy we need to follow, that is instance name or the module instance name, that is w1. In this w1 instance I need to change what? Only the parameter value for this parameter. That means id num equal to 1. That means id num got updated. And similarly w2 dot id num equal to 2. That means this identity number also got updated. So the parameter values are getting updated in this manner by using the defparam keyword. Okay, so as I have mentioned you that it is a bad coding style, because we need to use in this manner, which makes some of the programmers like kind of uneasy. They may have some kind of uneasiness by using this defparam keyword, and also considered as a bad coding style. So as I told you that the second technique is we don't have to use any defparam keyword. So that means module instance parameter value is the second type of overriding parameters technique. Like for example, as I said you, if multiple number of parameters are defined in the module, so I am having here the module name, that is Indian Railways, and minimum time, typical time and maximum time. So Indian Railways is my module name. That means I am having here my multiple parameters. So during the instantiation, that means Indian Railways module instantiation, so these minimum, typical and maximum time can be overridden. So by specifying the new values in the same order as the parameter declaration in the module as the parameter declaration. So module top. So Indian Railways is instantiating three rails here. So Indian Railway is instantiating Ajanta Express, one thing. Yeah, one is Ajanta Express, it is instantiated, and Indian Railways Krishna Express, it is instantiated, and next one is this instantiating Narsapur to Nagarsol Express. It is. So three instances I can able to see here, and then the instance names are these three: Ajanta, Krishna, and Nagarsol, Narsapur. So so here I am having parameters, that is minimum time, typical time and maximum time. Nothing but each and every time, each and every instant, each and every train is taking certain amount of time to reach to some point from some other point. So for example, from point A to point B, one rail or one train is consuming 240 minutes, minimum time of 240 minutes and typical time of 300 minutes and maximum time of 360 minutes, which is considered as the worst case. So this is what I have designed the code, and some module internals will be present here. So module top, Indian Railways. So as I have said you, right, so the parameter values for this Ajanta Express are overridden by specifying the new values in the same order as specified in the parameter declaration of modules. So in the parameter declaration of modules, in the some order I have maintained, that is minimum, typical and maximum. In the same order, the values can be overridden. That means agenda express from point A to point B, it is taking minimum time of 180 minutes, typical time of 195 minutes, and maximum time of 210 minutes. Similarly, Krishna Express is taking minimum time of 230 minutes, typical time of 240 minutes. So I don't have any new value or the new parameter is assigned or specified here. If nothing is specified, by default what will be the maximum time that has to be considered here itself also. Okay, so this is what this is parameter value assignment by ordered list. So in the next category, parameter value assignment by naming list, we can able to see here. So Indian Railways have instantiated Nagarsul, Narsapur, Nagarsul instance name this is, and so parameter value assignment by naming list. So parameter typical time, of course it is a parameter, maximum time it is a parameter. You can see here typical and maximum, these two parameter names I am having here, but I didn't find minimum time parameter name. So that means parameter values for the parameter names, for the parameters name typical time and maximum time, its parameter values are only getting updated. So now 260 is the parameter value for your typical time parameter and 270 is the parameter value for the maximum time parameter. Then what will be the value for your minimum time parameter for your Narsapur Nagarsul? That means Narsapur Nagarsul from point A to point B, what will be the minimum time it is consuming to reach from source to destination railway stations. So if I didn't mention anything here, by default it is considered whatever is present in the module during the time of module declaration, module parameter declaration, that value is only considered here by default, that is minimum time equal to 240. And next is end module. So in this way the parameters can be overridden during the time of module instantiation process. So these are the two techniques that comes under this category. Okay, next is we do have here conditional compilation and conditional execution. So what is the purpose of conditional compilation and conditional execution is for example, in our condition compilation, if I want to compile only certain portion of my Verilog code, that means I do not have any tendency to compile the entire Verilog code, only certain portion. That is, a designer can specify a particular portion of the code to be compiled if certain flag is set. This concept is called conditional compilation. And similarly, conditional execution is a designer might also want only certain portion or the part of your Verilog code to be executed. To be executed means it is definitely happening at runtime only. So this is the conditional execution. So of course there will be certainly the keywords definitely required for performing these two tasks. The keywords here we use are tick if def, that means here backtick if def, backtick else, backtick else if, backtick end if, and backtick define. So these are the keywords that we use here for the conditional compilation purpose. And similarly for the conditional execution, that means the designer will have the designer wants to control some statements execution flow. That means he want to execute certain number of statements and he doesn't want to execute some other statements. So during this time, like how to define, how to implement this one, like we definitely have to use certain keyword for this one, that is $test $plus rx. So let me explain you this in brief. So let me go with conditional compilation first, and we'll come back to here. Yeah, this is the conditional compilation. So tick if def test module test and the module else. Okay, I will explain this example. Yeah, so it is conditional compilation, and let me create in design block itself module top. Yeah, so you can able to see I'm having module top and my inputs are ACEGI, outputs are BDFHJ. So let me define my some module, that is bus master is my module name, input is x and output is y, and the module definition is assign y equal to negation x. That means an inverter operation this bus master module is performing. Okay, now coming back to here, I am having module top. So inputs are ACEGI, outputs are BDFHJ. So bus master module is instantiating B1 and the instance name is B1 here. That means B1 is instantiated unconditionally and its inputs and outputs are following the same how I have defined for during the time of my module definition. In the same order I need to follow the sensitivity list here also. So the argument list I can say. So A is the input, B is the output, and similarly bus master is instantiating B2, it is instantiating B3 and B4 and B5. So my my question is, will all the instructions are getting compiled in the program is my question. So let me check. If it is compiled, definitely we are going to get some of the technology schematic here. So like we know that tick define directive is yeah, it is actually an earlier discussion itself. Tick define directive generally used to define the text macros in our Verilog HDL. Main purpose is the Verilog compiler just substitute whenever the text of the macro, whenever it encounters the macro name, right? Okay, so that means why I am discussing about tick define, I will explain you now. So before it, as we do have certain keywords like tick if def, tick if and def, tick else if and tick end if to accomplish the conditional compilation. So we also call these sometimes as a compiler directives also. So this can be placed anywhere in the program. One thing is okay. So here bus master B1, this B1 is module is instantiated unconditionally, first thing. So tick if def at B2. So if this flag is defined, yes, this flag tick define add v2. So the flag is defined here by tick define. Okay, so tick if def address v2. If this flag is defined or set, I will instantiate b2 module. So b2 instantiated is instantiated how? Conditionally. What is the condition? If def, that means if this flag is defined, if this flag is set, yes, this flag is defined, that means I am instantiating. So b2 got instantiated. Okay, tick else if. Okay, at least check now. Add b3. At least check whether this flag is defined. No, I didn't define here. Okay, that means b3 will never be instantiated. Else, bus master b4. So why do I have to go with else condition if my if condition is satisfied? Anyhow, if condition is satisfied, so there is no requirement for else condition. And if I have started, tick end if I need to end it using tick end if directive. Now after this one, tick if not defined. So ignore b5. If ignore b5, if this flag is not defined, have defined here? No, I didn't define. So I didn't define means b5 will be getting instantiated conditionally only. So end if end module, because if tick if I have used it means definitely tick end if I need to close the compiler directive. Okay, that means according to conditional compilation, the theme of this conditional compilation is the designer can specify that the particular portion of the code can be compiled by only by certain flag is set. So only certain flag is set means, so here it is compiled. So I am anticipating that the instructions which are getting compiled here is this one. Let me write here this one, b1, b2 and b5. These all will be getting compiled, and b2, b3, b4 are ignored here. Why? Because according to the conditions this flag is set and the remaining three flags are not set. b3, b4 are not set, and ignore b5. Of course I didn't define here, so this is based on if and def, that is if not defined. So this flag is not defined, hence this will be compiled. So once, let me compile this one. Yeah, so once let me check the syntax of it. Yes, b1, b2, b5 only the Verilog code compiler had considered only these modules, that is b1, the compiler had considered b1, b2 and b5. You can able to see here, right? And so whenever this portion of the Verilog code is compiled, we can able to see its RTL schematic also. That means the Verilog compiler had ignored b3, b4 as well as, yeah, b3, b4 only it has ignored, right? It's taking very long actually. Right. Yeah, this is my top module. Inputs are A, C, E, G, I. Outputs are B, D, F, H, I. Once I double click this one, I will be getting the instances names. You can able to see here b1, b2, b5. The compiler have considered these b1 instance, b2 instance, b5 instance, because these three, b1 is instantiated unconditionally, b2 is instantiated conditionally, and b5 also instantiated conditionally. This is nothing but your conditional compilation. And what is this conditional execution? So let me also demonstrate you the conditional execution here. For the design block, I am developing here the test bench. Let me keep the margin for the test bench as test. Yeah, for the top itself. Next, finish. Right. Control B. Okay. So module test, and these are the signals that have to be passed. Register ACEGI. ACEGI are nothing but input signal that have to be passed in your into your top level design block. And BDFHJ are the output signals which are to be extracted from your design to, that means we need to verify the functionality. That is why we are passing the signals and we are extracting the signals from the to and from the test bench, from the design block. So the design block have to be instantiated. Top is my design block and the instance name is T1 here. So all the input signals and output signals, the same order, the arguments, how I am mentioning, it has to strictly follow the same order how I have followed here. Okay. And the initial begin if $test $plus rx display var. So if this is satisfied, display equal to BDFHJ, all the output signals will be displayed in your console window. Else only this one will be displayed. That means no display or something, whatever we are writing here, the text that can be displayed in the console window. Okay, so only if flag is set, only if this flag is set, okay, this will be executed, else this will be executed. So I am not going to set the display var flag anywhere here. Okay, so initially I need to pass some input values, that means proceed continuous assignments or some kind of assignments I have to do here to all my input signals. A equal to 1, C equal to 0, E equal to 1, G equal to 0, and I equal to 1. So end module. Let me check the program, let me run it. Yeah, you can able to see here I didn't get F and H. F and H are showing here an high impedance value, and remaining all are having some logic 0, logic 1, 0, 1, 0, 1, 0, 1. Why? Because in the design block, the compiler had ignored B3 and B4. So for which B3 and B4 are having outputs F signal as well as H signal. So the compiler had ignored them. Definitely the test bench in the waveform window we may not get the values, and we can able to see the high impedance values. And so this is the concept of the conditional execution is $test $plus args. So is my flag is set, display var flag is set here? No, I didn't set it. So if it is set means I can able to see these BDFHJ output values. but the flag is not set. So the simulator had taken this to be for execution, that is no display. So no display here. So here the syntax task, I mean to say the task, system task, actually it is what that is a system task $test plus args, which is especially used for conditional execution, and this keyword supports only for some specific simulators only, like model sim or verilog excel simulator, and for few other simulators, and I don't think it supports for isim, I'm not sure, so that is why let me check this one. Yes, I have got some error. So thing is, the $test plus args keyword, it is not actually a standardized keyword, and it is only supports to some specific simulators only. And that is why I didn't able to get the BDFHJ values in my console window. Okay, so like for example, in our PPT slide, you can see here, so the same program I have written here. If $test plus rx display where $test the display defined, else not defined, display not defined. So which simulator he is using, let me check here. Yeah, he is using model simulator of mentor graphics, I think. Yeah. So like if this keyword is defined, if this system task keyword, that is $test plus rx is supported to this, that means this keyword, if it is supporting to the model sim simulator, you will definitely going to get or going to see defined in your console window. So let me check, will I able to get defined? Yeah, I have got here defined. You can see here in this area. That means your model sim is supporting $test plus rx for your conditional execution purpose. Okay, so this is about conditional execution now. Okay, so that's it, and the remaining concepts like timescale directive, as well as some more useful concepts like some more useful system tasks, we will discuss in the next session. Okay, thank you for the day.